Assalamu alaikum dear students. Today we are going to discuss the algebra of the complex numbers. Now the first one is the addition. Let z1 equals to a plus iota b and z2 equals to c plus iota d. That is, z1 and z2 are the two complex numbers. Then the sum of these two numbers, that is z1 and z2, is defined as z1 plus z2 is a plus iota b plus c plus iota d. Now here a is constant, c is constant. That is constant in the sense they are independent of these iotas. So we simply add these two numbers, a plus c. Now iota b plus iota d is simply iota b plus d. So here a is real, c is real, because these are the real parts of the complex number z1 and z2. So is a plus c, which is also real number. Also b and d are the real numbers, that is imaginary part of z1 and z2, which implies that b plus d is again real number. So we have real number of the form of this complex number of the form of a plus c is the real part plus iota b plus d, which is also the imaginary part of this complex number. Hence we can say that sum of the two complex numbers is again a complex number, and the real part of the resultant complex number is the sum of the real parts, because a is this real part of z1, c is real part of z2, and imaginary part equals to the sum of the imaginary parts of the individual complex numbers. Like if we consider z1 equals to 2 plus iota 3, z2 equals to 5 plus iota 4. Here the real part of z1 is 2, imaginary part is 3, while as a real part of z2 is 5 and imaginary part is 4. So z1 plus z2 is 2 plus iota 3 plus 5 plus iota 4, which is simply by adding real parts, that is 2 plus 5, and by adding the imaginary parts, that is 3 plus 4, which is 7. Hence z1 plus z2 is the complex number 7 plus iota 7. Here real part of this resultant uh, complex number is 7 and imaginary part is 7, which is equals to the sum of the individual real parts, while as imaginary part, which is 7, is also equals to the sum of the individual imaginary parts. So this is about addition of two complex numbers. So addition of two complex numbers is again a complex number, which implies that set of complex numbers is closed under addition. That is, whenever we add any two complex numbers, the resultant is again a complex number. This means the set of complex numbers is closed under addition. Now subtraction. Now if we have two complex numbers in the same way, z1 equals to a plus iota b, z2 equals to c plus iota d, then their difference is z1 minus z2, which is a plus iota b minus c plus iota d. Now here minus is common to c plus iota d, so we break this, it is minus c minus iota d, which is again by separating these terms, a minus c plus iota b minus iota d, which is simply a minus c plus iota b minus d. Now a is real, c is real, implies that a minus c is real, b and d are real numbers, which implies that b minus d is real. Hence subtraction of these two numbers, that is complex numbers, is again a complex number whose real part is difference of the real parts and imaginary part is difference of their individual imaginary parts. Like if we consider z1 equals to 5 plus iota 2 or 2 iota, and z2 equals to 1 plus 4 iota or iota 4, then difference is a difference of the real parts, that is 5 minus 1, and a difference of uh, imaginary parts, that is 2 minus 4. Now here 5 minus 1 is 4, 2 minus 4 is minus 2, that is z minus z2 is 4 minus iota 2. Hence a real part of two complex, these real part is difference, while as it is imaginary part is difference of the imaginary parts. That is, here imaginary part of this z1 minus z2 is minus 2, minus 2, while as its real part is 4. Now you can easily check that z1 minus z2 is not equals to z2 minus z1, because difference of two real numbers is not in general commutative, or simply we can say that z1 minus z2 not equals to z2 minus z1 in general, while as addition is always commutative, because a plus c is c plus a, while as b plus d is d plus a in this in addition of two complex numbers. Now properties of the addition of two complex numbers. Now you know that closure property, that set of complex numbers is closed under addition, that is whenever we add any two complex numbers, the resultant is again a complex number, or their sum is again in the set of complex numbers. Similarly, under subtraction, it is still closed, because difference is always difference of two real numbers is always real. That is why difference of two complex numbers is always a complex number, hence they are also, or set of this complex number is also closed under subtraction. Now the second property is the commutative property. Now you know that addition of two numbers or addition of two real numbers is commutative, which implies in general that this addition of two complex numbers is also commutative, that is z1 plus z2 is not equals to z2 plus z1, while as z1 minus z2 not equals to z2 minus z1. In general, you can easily verify it. Now third property is associative property. Now for any three complex numbers z1 z2 z3, z1 plus z2 plus z3 equals to z1 plus z2 plus z3. That is, we have to firstly solve this z1 plus z2, then add the resultant complex number with this z3. Then if we add second and third, and if we add this resultant complex number with z1, then both are equal, that is z1 plus z2 plus z3 equals to z1 plus z2 plus z3. This is the associative property, or set of complex numbers satisfy associative law. The fourth one is, additive identity. You know that if we consider a set of real numbers, and you know that if n is a real or a is real, and n plus 0 is always, or a plus 0 is always a, that is 0 is called as the additive identity. Now if we consider a complex number whose real part as well as the imaginary part is 0, this is called as the zero complex number, or simply the zero, or simply the zero in the complex set. We denote this simply by the bigger zero, that is this. Now for any complex number, if we consider any general complex number a plus iota b, then z plus 0 is a plus iota b plus 0 plus iota 0, because 0 is the complex number whose real part as well as the imaginary parts are 0. Now when we add these two, a plus 0 is 0, a, b plus 0 is b, which implies that again it is z, because z is a plus iota b. Hence 0 is the additive identity in the set of complex numbers. This 0 is simply 0 plus iota and 0. Now what is additive inverse? Now if we consider a real number a, then there exists minus a such that a plus minus a equals to 0. This is called as the additive inverse in the set of real numbers. Similarly, if we consider here a complex number z equals to a plus iota b, then minus z is minus a minus iota b. If we add these two numbers z and minus z, because if z is a complex number, then minus z is also complex number. Its real parts and imaginary parts are simply the negatives of the real and imaginary parts of the given complex number. Then z plus minus z equals to a plus iota b plus minus a minus iota b, which is simply 0 plus 0 iota, or simply the zero complex number. So there exists additive inverse for any complex number. You can also check this minus z plus z equals to 0 also. So this minus z is simply called as the additive inverse of complex number z. So inshallah in tomorrow's lecture we will discuss the multiplication of two complex numbers and the properties of the multiplication of the two complex numbers. So thank you.